Hello students, today we are going to see something important and interesting question. And one more thing, repeatedly they are asking that question. Okay, let us go and find out. I would like to give some repeated important questions in this session. Okay, now in that first question, consider the three types of replacement of the group X by group Y. Okay, now this is that middle point here. A and B, group X replacement of group Y. So here A plus B combine. Here A compound and B compound. What are the question arises from here? The first question, A only compound obtained. So what compound obtained? Which reaction takes place? What mechanism find out? Okay, that B only compound obtained. Then A and B are formed in equal portion. Okay, actually it is like easy one only. We know already this point, but indirectly they are asking the question. So how to find out? See, as you are looking only wedged line, dashed line, already you have gone through those points and all in grade 11. So as you are looking only the compound, this compound, as you are looking the same structure only, there is no changes. See, look at that. Now you just see here C2H5, here CH3, here dashed, this side wedged, this side dashed, and the same way here also the same wedged side and dashed side. That is wedged and that is same as it is. So the compound A only compound obtained. So that means it is a retention configuration. As we are talking about retention configuration, the symmetry of the substance before and after reaction also it will be same structure. That means it remains dextro-rotatory. Now look at this picture. Here C2H5, here CH3, here dashed line, and here this wedge line. The same way CH3 dashed line hydrogen, C2H5. So the same structure, that means it remains the same position dextro-rotatory. So that is retention configuration. What do we call? Retention configuration. Okay, so this is retention configuration. Okay, now retention configuration, now you know very well. Generally, retention configuration, when it will takes place, you know, in that SN1 reaction only it will takes place. When it will takes place? It will takes place only in that SN1 reaction. Now, come to that next point. Here, the next question they asked, compound B, compound obtained. Now, as you are looking, this is C2 C2H5, CH3, this is this side. Whereas this side, here, look at this, just the opposite. Walden inversion, inversion of configuration. You have gone through, no, the same point I would like to mention. So this is SN1 reaction, retention configuration, it will be same. Walden inversion, inversion of configuration, just to the opposite, that is SN2. Yes, I would like to mention SN2. Okay, so what is the name here? What will you bring the answer here? Here, Walden inversion or inversion of configuration. So what do you mean by inversion of configuration? Suppose the substrate during the reaction time, substrate as in a dextro position, it will be changed into levo position. So that is called what it is? Inversion of configuration or Walden inversion. Okay, now what can you put it? Inversion. Inversion of configuration. Hope you are clear with it. Okay, now next one. So retention configuration takes place in SN1 reaction, and inversion of configuration takes place in SN2 reaction. Hope you're clear. Now third question, A and B are formed in equal portion. So when it will form it in an equal portion, you know, racemization mixture. So racemization mixture, it formed equal position of dextro position and levo position. So here, that's all, only 3 points. for that 3 marks. See, only one word it is. If you know the depth of that concept, you can bring the answer. As you are looking only, don't get afraid. You know the answer. You have learned SN1 mechanism, SN2 mechanism. What are the difference? What are the points to be noted? What are the ideas from that you got it? Those points and all you have gone through. Only thing, you should think it in a logical way. Now as you are looking only, this is the same position, this is just to the opposite. Now SN1, SN2, which one will be coming, which will be vary. So as you are looking only, you will come to know. Now final answer, what it is, equal portion. So racemization mixture, it forms equal portion of dextro and levo. Yes, it is what it is, dextro and it is levo. It is D and this is L. Got it? Okay, is it clear? So this is the last answer. What it is? Racemization. Racemization mixture. Hope you're clear with that. That's all this point. Yes, now let us go for some more important repeated question. Another one more interesting question, something typical question. Yes, as you read the question only, you will come to know what they are asking from that. Okay, from the compound A with the molecular formula C4H9. C4 starts with butane, right? So C4H9 is treated with KOH. The rate of the reaction depends on the concentration of the compound A only. So this is one question. When another optically active isomer B of the compound treated with aqueous KOH solution, the rate of the reaction found to be concentration of the compound and KOH. So first thing, the rate of the reaction depends on the concentration of the compound only. The second point, what they are mentioning, the rate of the reaction depends on compound as well as nucleophile. From that only we can identify SN1 and SN2 only they are asking. Like such kind of questions you will get. Okay, from this. Okay, C4H9. What is it, C4H9? According to the general formula, general alkane, no. So this is C4H9, CnH2n plus 2. According to that, so naturally, CnH2n plus 2, in that way, if we consider, means it is one point they mention C4H9. The other point they mention the rate of reaction depends on the concentration of the compound A only. So that means 100%. This is tertiary compound only it locates. So tertiary compound C4H9 BR. Okay, if you want to go for to check whether it is correct or not, CnH2n plus 2, if you go means 2 into 4, it is 8, 8 plus 2, 10. In that one hydrogen, it is replaced by bromine. So that means here, so here in that only one compound, that means it is a substrate only. It depends, the rate of the reaction depends only on the substrate, means 100% it is tertiary halide only. So tertiary halide, how will you write it? Here CH3, here CH3 and Br. Okay, now it reacts with aqueous KOH. Yes, now when this kind of reaction comes, when this kind of reaction takes place, this is SN1 mechanism. 100% it is SN1 mechanism. So naturally here what you will get the answer the same, but CH3 here, CH3 here, OH is replaced by Br. Okay, now I think this SN1 mechanism you have learnt thoroughly. Why I am bringing over here, so the rate of the reaction depends only on the concentration of the compound A only. So this is the compound A. Got it? So this comes under which reaction? The reaction comes SN1 mechanism. The second one, what it is, the second one, when another optically active isomer B of the compound treated with the KOH solution, the rate of the reaction found to be both concentration of the what it is, compound and KOH. So naturally that is SN2 mechanism. right? SN2 mechanism. Come on, let us go for that to check whether it is, that too they mention optically active. So the same compound, that means the same kind, C4H9Br only. So C4H9Br, what it is? CH3 CH. Optically active also they mention, okay? Optically active, okay, we can put it 2-bromobutane, CH2, CH3, okay? 2-bromobutane combined with aqueous KOH. This is 100% SN2 mechanism because the concentration depends on both the substrate and the reagent. Yes, okay. Now what is the answer? You will get it. The same here. CH3, CH, here OH, CH2, CH3. Okay, now this is optically active. Why you know? This carbocation formation, here is the carbocation formation. OH will go and attack in that. So when you are looking in that way only, so this is SN2 mechanism you can identify. Now from that you can come to know. Now the third point in that question they ask, write down the compound A. Yeah, I have given that, write on the compound A. I have given the tertiary halide. Now in the next one, out of these two compounds, which one will be converted into that product inverted configuration? Which one will find out inverted configuration? Can you guess? Here they mention inverted takes place, inversion takes place in SN2 mechanism, 100%. Okay, C4H9, we can write it in this way, carbon connected with C2H5 and here CH3, 2, 3, 4 and here what it is, hydrogen, here bromide. Okay, now here in this OH will go and attack where it is, OH minus will go and attack the side from the back side, right? You have gone through, right? Now you will get what it is, transition state. What is the transition state? Here carbon connected with it, here CH3, here C2H5 and here Br, which is what it strengthened less, and here OH minus ion, that carbon and connected with the hydrogen will be more stronger and this will become weak in the transition state. Why? Because OH minus ion, it's going to attack the carbon from the behind, so automatically the bond between the carbon and bromide, that bond will be loosening the strength, whereas here OH minus ion and carbon, it will become, the bond will be become strong enough, so automatically it breaks that and you will get the transformation inversion configuration takes place. So how you will get it here in this point, here carbon, here connected with, here CH3, here C2H5 and this is hydrogen. From back side it is OH minus ion. So from this the inverter takes place, no? It is inversion of configuration. Hope you're clear with this. Okay, so in that first question, it is tertiary halide, SN1 mechanism. The second question, both of them, it is having that concentration power. So that means SN2 mechanism, SN2 reaction. And third one, what it is, write down that compound A and B. Yes, you know that first compound what it is, second compound what it is. And the next question, what it is. Out of these two compounds, which one will get that inverted configuration? Of course, SN2 mechanism. Yes, N2 mechanism get that inversion of configuration, that is Walden inversion. Hope you're clear with this. See, now here the CH3 C2H5 Br, just like that. Now here just to the opposite side, okay, because OH minus ion which is going to attack over here. Hope you're clear with it. Okay, we'll see some other questions. Here, let us go for one more question. Before going there, I wanted to mention the last question. It is very, very important. 2016 they asked, and it is like higher order question they mentioned. I wanted to mention that time only. Okay, now let us go for this. This is also something indirect question only. See, when you are going through this, diphenyls are potential threat to that environment. This is like informative, right? Yes. Now what they are asking, how are these produced from aryl halide? Aryl halide converted into diphenyl. Aryl halide into diphenyl. Yes, it's Wood's reaction. Yes, chlorobenzene, sodium, and in the presence of dry ether. Yes, you got the answer. See, simple. Already you know the answer. Only thing you should think it in a proper way so that automatically your answers are there in your hand. Okay, now it is aryl halide, no chlorobenzene only. It's chlorobenzene. So chlorobenzene, how will you put it? Cl. Okay, now two molecules of chlorobenzene reacts with metal of sodium in the presence of dry ether. You are getting diphenyl. That's all the answer. Okay, sodium 2 moles, and here I just put it this way so that it will be easy for you. Okay, you just put the box. What happened here? 2NaCl. You are getting what it is? Biphenyl, or diphenyl. See, from the word only, see, only one thing, conversion. From that conversion only we have gone through. See how they are asking the question indirectly. Okay, you should be thorough, think it in a logical way also, so your answers will be in your hand. Okay, now here in this, in the presence of dry ether, hope you're clear with this. This is called diphenyl or biphenyl. Biphenyl. In the question they mentioned diphenyl, you can put it diphenyl also, no problem. Diphenyl. Okay, is it clear? Okay, we'll go for the next question. You know, when they are asking 2020 CBSE board, they asked. Okay, now we'll go for some other question. In this point, I would like to mention in an easy way to remember that tricks for naming reaction. You know, I just mentioned the first one, exchange of halides. Suppose they are asking the question, give one example of exchange of halides. See, in the two reactions are there, Fenkelstein's reaction, Schwarz reaction. Fenkelstein's reaction, methyl chloride reacts with sodium iodide. You are getting methyl iodide. Okay, I think you just see my video. I have given Fenkelstein's reaction, and I mentioned that note also. Methyl chloride reacts with sodium iodide only in the presence of dry acetone, whereas sodium bromide and sodium chloride do not react with methyl chloride. Why? Because sodium bromide and sodium chloride do not sink, that means do not dissolve in dry acetone. That is what it has mentioned. Okay, now here that is Fenkelstein's reaction. Schwarz reaction, what is that Schwarz reaction? Exchange of halogens. Here fluoro compound, what it is, chloro compound converted into fluoro compound, that is in the presence of metallic fluoride. I just mentioned that metallic fluoride. Okay, so this is one. This one, it is metallic fluoride. Exchange of halides. So in that way you can remember. Okay, Schwarz reaction and Fenkelstein's reaction comes under exchange of halides. Okay, the next one, conversion of diazonium salts. Amine chapter also you will be knowing, and here also they mentioned. Okay, so here Sandmeyer's reaction, Gattermann's reaction, Schliemann's reaction. These are the point. Main compound, what it is, that substrate it is diazonium salt only. Okay, now conversion of diazonium salt into chlorobenzene. Okay, first one, Sandmeyer's reaction. It's very simple. What it is, you know, diazonium chloride reacts with cuprous chloride in the presence of HCl. You are getting what it is, chlorobenzene. And Gattermann's reaction, instead of cuprous chloride, you are getting a copper powder. So diazonium chloride reacts with copper powder. That is a Gattermann's reaction. And Schliemann's reaction, diazonium chloride reacts with fluoroboric acid. You are getting fluorobenzene. That compound will be very, here chlorobenzene, here fluorobenzene, fluoroboric acid. No, so you are getting fluorobenzene. Okay, we'll give some more ideas for that. What it is, naming reaction. I think you have gone through 1, 2, what it is, 3, 4, 5. Yes, let us. The next one, it is Williamson's synthesis. Williamson's ether synthesis only, sometimes they'll give that question. So conversion of ether formation, you know, haloalkane reacts with sodium ethoxide. You will get ether formation. You know what is its ether formation? ROR dash. So that is ether formation. And hand sticker reaction, conversion of ester formation. This is actually silver carboxylic acid of salt. Okay, salt of silver carboxylic acid. So you will get ester formation or COO or dash. Okay, that hydrogen, that OC carboxylic acid or COOH, no, the hydrogen is replaced by one more alkyl or aryl group. Okay, now here silver salt or COOAG. Okay, silver salt of carboxylic acid reacts with the haloalkane. You are getting ester formation. Then Dorson's process, alcohol converted into haloalkane, thionyl chloride. Hope you remember all those points. And Stein's rule, beta elimination, and Markovnik's rule, anti-Markovnik's rule. Hope you are clear with that. And next one, elimination. Substitution reaction, number of times repeatedly they are asking indirect way question also. Okay, now next one, what it is? SN1 reaction, SN2 reaction, mechanism, difference, all those things, and Woods reaction, Woods Fittig's reaction, all those points and all you should be remember. Woods reaction, Woods Fittig's reaction, Woods and Fittig's reaction. On these questions and all number of times they are asking from the board. Okay, hope you remember all these points. Next session, let us go for the competitive way. If we are thorough all these concepts, no, competitive way, we will answer very clearly and we will be more confident. Hope you are clear with that. Thank you. Thanks for watching.